Hello dear students. Let's start with one important topic of negative skin friction. So whenever a pile is experiencing downward drag, let me show you by drawing a diagram. So suppose this is the pile and some load is acting over it. This is a fill material. This is some soil fill material. This is loose soil or very soft soil. We can say loose soil or very soft soil. So here what will happen, ideally the friction should be in upward direction, but because here the pile is surrounded by loose soil, so there will be downward drag, okay, like this. So the pile itself is going down, okay, and the soil is also going down, okay. So this is known as negative skin friction, okay. And here suppose we are having dense soil, so here there will be actual friction which will act in opposite direction to the direction of your pile, okay. So this is your pile which should ideally go in downward direction and the friction should be in upward direction, okay. So when a soil layer surrounding a portion of the pile settles more than the pile, okay. So basically it is a, we can say, downward drag. Remember this term, downward drag. Okay, now one more thing which you should just I am mentioning this point, okay, let me write. Negative skin friction increases gradually as the consolidation of clay layer proceeds, since the effective overburden pressure gradually increases. Due to dissipation of excess pore water pressure, right? So now remember one thing, suppose for cohesive soil, QNF is equal to perimeter multiplied by L1 alpha C, okay. This is for cohesive soil. What is QNF? QNF is total negative skin frictions, okay. So we have seen this is your pile, okay, and this is your fill area. So this is loose soil. So this is your L1. Okay. Suppose this is your dense soil. So it will be, this distance is L2. Okay, so here we are concerned with L1. L1 is the thickness of the loose soil. Basically, this is the thickness of loose soil. Then factor of safety FOS is equal to QUP minus QNF divided by the applied load. We have seen applied load is your capital Q. Okay. Another thing, for cohesionless soil. Okay. So for cohesionless soil, here the formula will be QNF is equal to P multiplied by force per unit surface length of pile. Okay, so the formula is P multiplied by half K gamma dn square 10 delta. So ultimately QNF is equal to half P dn square K 10 delta into gamma. See here, the friction force is equal to mu into H. Gamma is equal to unit weight of soil. We all know what is K? Earth pressure coefficient. This is standard. Active earth pressure is less than your earth pressure coefficient K is less than passive. Kp means passive, Ka is active. Okay, and delta is angle of wall friction. So the range is phi by 2 less than delta less than phi. This is the range. Now let us discuss regarding the group efficiency of pile. Group efficiency of pile. The formula is eta g is equal to QUG divided by NQUP. Okay, N means number of piles. Okay, here small n represents number of piles, total number of piles. And what is QUG? So G stand for group. So it is ultimate load capacity of pile group. And QUP, it is ultimate load on single pile. Okay, so remember this thing. Suppose it is for sand soil. Okay, so eta g, your efficiency of group is greater than 1, and suppose it is clay soil, so it may be less than 1 and greater than 1. Now suppose if we are dealing with under rim pile, so in case of under rimmed pile, our ultimate tensile capacity will be due to three factors. So first factor is friction along the length of pile. So this is basically surface area. It is concerned with surface area, friction along the length of the pile. Let me name it as P1. Then second is bearing action. So caused by under rimmed portion. So here I am writing P2. And third is your dead weight of pile. So remember these three factors for which are responsible for ultimate tensile capacity of the pile. So dead weight of the pile, let me write P3. So basically dead weight of pile P3 is constant. Okay, constant means whatever will be dead weight, that we have to accept. Okay, but what is the formula of P1? P1 is equal to FSAS. Basically stress is equal to force upon area. So force is equal to stress into area. So Fs into S. So this is Fs is your stress. This part is your stress. And this part is area. Now how to calculate AS? AS is equal to alpha C pi dl. Okay, so alpha, we know alpha is adhesion factor. Now C is cohesion, or sometimes they are writing undrained shear strength. D is your shaft diameter. Okay, let me write DO because it is shaft diameter. Okay, so that we can differentiate. Under rim diameter is different and shaft diameter is different. Okay, so don't make this mistake. Length. Okay, see, we know this is your in case of under rim pile, it is like this. Okay, like this. So this diameter, this is DU and this is DO. Okay, remember this thing. So basically area A is equal to pi by 4 du square minus do square. Okay, so du is under rim diameter and do is shaft diameter. Okay, now what about P2? P2 is equal to CNC A. NC will be given to you, bearing capacity factor. Okay, so therefore can I write ultimate tensile capacity is equal to P1 plus P2 plus P3. So if we add all this, we will get the ultimate tensile capacity. Now regarding ultimate load capacity of a pile, ultimate load capacity of a pile, how to find out? Now see, this is of course single pile. Okay, not a group. This is single pile. So QUP, the notation will be QUP is equal to CNCAB plus alpha CAS. Now see, this term is related to end bearing or point bearing, and this term is referred to friction. So ultimately see, here I am drawing, whenever a pile is driven in the soil and some load is coming, so ultimately it is resisting the load due to two things, two factors. One is your friction, this is your friction, okay, and another is your this area, this is end bearing or point bearing. So there will be some resistance, okay. So end bearing, the term CNC, C is your cohesion, NC is your bearing capacity factor, C is cohesion. AB is your area of base, which is pi by 4 d square. In case of circular, obviously it will be pi by 4 d square. And suppose the soil is clay, remember it, for clay they may not give you the value of NC, but you have to remember NC is equal to 9. Okay, now regarding this second term, this for friction, alpha CAS, alpha we know it is adhesion factor, C is cohesion, and what is AS now? See, AS is different from AB. AB is your area of base, pi by 4 d square. AS is surface area on which the friction is acting. Okay, so surface area of cylinder, because basically pile is in circular cross section, so the surface area will be pi dl. So L is your length of the pile, okay, and d is your diameter. Okay, so remember this thing. This is very important formula to find out the ultimate load capacity of a single pile, single circular pile, that too circular pile. Okay, so if I have to find out efficiency of pile group, we have one more formula which is also known as Converse-Lebesgue formula. So eta g is equal to 1 minus theta upon 90 m n minus 1 plus n m minus 1 divided by mn, and theta is equal to tan inverse d upon s. So remember this formula, where d is diameter of pile and s is spacing between pile. Okay, so just write down. I will show you by drawing the figure. See here, suppose this is a pile group. It is 4 by 4. Basically m is equal to 4, n is equal to 4. 4 rows, 4 columns. Okay, so mn value we can get from the number of rows and number of columns. Okay, then D is the diameter of the pile and S is the spacing. Spacing means center to center. This is the spacing. See, this is S. This is S. Spacing. Okay. And this is your half diameter and here also half diameter. Okay. So that will be extra. But the spacing will be S. And this is your total is your D. That is diameter. So theta will be tan inverse D by S. But suppose, see, I told you the formula for QUP, here I am writing, QUP is equal to CNC plus alpha C AS. Okay, so this is for friction and this is for point bearing. Okay, point bearing, point or end bearing, and this is for friction, rather skin friction. Okay, so whenever they are asking to find out net ultimate pull out, so we have to just find take into account this term alpha CAS or alpha C. If it is circular, then alpha C into pi dl. Okay, remember this thing. Okay, no need to add the term CNCAB. If they are asking to find out net ultimate pull out load, so it is alpha C AS. And if they are asking friction ratio FR, so basically it is a ratio of QS by QT, that is sleeve friction, or we can say side friction divided by tip friction or base friction. Okay, remember this thing. Friction ratio is the ratio of sleeve friction to tip friction. Sleeve friction is also called side friction and tip friction is also called base friction. Okay, thank you very much.